Hello everyone. Today we are solving question 88, that is merge sorted array of lead code, right? So here we are given two matrices num1 and num2 and we need to merge both of them. The point you need to notice is that both array and the resultant array are sorted, right? Num1 has length m, num2 has length n, and we need the resultant matrix that has length m plus n, right? So as you can see, num1 elements are 1 2 3 and num2 elements are 2 5 6. So after merging both of them, elements are placed in ascending order, that is 1 2 2 3 5 6. Yeah, so we will see how this process is being done. So I just wrote the test cases here, n1 1 2 3 and 2 2 5 6, and the resultant matrix size m plus n. Just notice size, right? The first thing, like what intuition you can just, and the conclusion that you might be thinking, like how can I begin? Since the array is sorted, since sorted, what does it mean? Sorted means elements are placed in ascending order. What does that mean? To means n1, like if I choose n1, like so n1 array index 0, like the element placed at index 0 must be less than element placed at index 1, that must be less than element present at index 2, right? Of course you can see here 1 less than 2 less than 3. So what can I say for n1 matrix? That the element present at index 0, that is the minimum element, right? This is minimum for n1. Same I will be saying for n2, right? 2 is the minimum element, right? And for resultant array, what I can say, the element that will be pushed in at index 0, that should be minimum, right? So after merging, like we need to merge this one. So either one can be pushed in or either two can be pushed in, right? They both are the potential candidate for this index 0, right? So what we'll do, we'll just put a if condition, right? If n1 I is less than n2 j, right? Like if n1 is less than, so what we'll do, we will wait. What we'll do, we will just of k, like k is the pointer of, see, I is the pointer of n1, j is the pointer of n2, and k is the pointer of resultant matrix, right? So we will just push n1 I here, like if I is smallest, since we need smallest at index 0, right? Since sorted, it give sorted diya tha, so we'll compare, right? So n1 0, like we will apply for while condition, while I is 0 and j is 0 2, right? So we'll compare, like 1 less than 2, yeah, it's true. So what we'll do, we'll push 1 here, right? Once we push in, we will increase the pointer next here, and this pointer 2, right? Okay. Now we need, now you need to notice that 2 and 2 both are matching. Since both are matching, you can push both of them, right? So I just pushed here both of them, like k here and like k should come here. Yeah. So I here, and I just increase the pointer value here, right? Now I have to compare 3 and 5. Of course, 3 less than 5. So I pushed in 3. Now you must be thinking, what shall I do now? Yeah, so this is case number 2. Since this is case number 1, like let me explain what is case number 2. Wait, case number 2. So first see this case, then we'll go in case 1 again, right? So in case 2, it's given 10, like n1 matrix is 10, 11, 12, 13, and n2 is 1, 2, 3. So case 2 says that when elements are exhausted. What does I mean by exhausted? I will explain you. Like if I apply same condition here, that n1 I is less than n2j. Like if this happened, what we'll do? We'll just push element in resultant matrix, right? So 1 less than 10, right? Like, well, let me put pointers I, j, and k, right? So 1 less than 10, of course, it's true. So we'll push I 1 here, right? Since this happens, so what we'll do, we'll increase pointer here again, and k will be increased 2, right? Now we'll compare 2. 2 with 10 again. Of course, 2 is greater. Then again we will change the pointer and k pointer 2. Again 3 is less than 10. Yeah. So you can see n1 element are exhausted, but sorry, n2 element are exhausted, but n1 element are still left. In that condition, we won't do nothing. We will just push in all element of n1, 10, 11, 12, 13. Yeah. So just remember, when element are exhausted of any of the matrix, you need to just push in all the element of another matrix, right? As you can say, 1, 2, 3 pushed in, 5, 6 are left. So you can push back directly 5, 6, right? So we will see, like I just explained you, we will see just coding in lead code, right? So what can I do? Since the m element that is given here, that is the size of num1 and n2 size of n2, right? So we need to create another matrix of size m plus n. So we'll do vector int m plus n, right? Yeah. Now we need to create 3 pointers for num1, num2 and resultant array, right? So int I is 0, int j is 0 and int k is 0, right? Now we need to put a while condition to while I less than m. This means element aren't exhausted. Like I am pointing this because element will not get exhausted. Like if they are exhausted, we'll put another while condition, right? And j less than n, right? Yeah. Now we'll put our if condition. If nums1 I, okay, wait, nums1 I, oh shit, yeah, nums1 I is less than nums2 j. In that condition, what I need, like, oh shit, I just forgot to name this. Like I'll name it as answer, right? So answer of k is equal to nums1 I, right? And when this happens, you need to just uh, uh, increase the pointer. So I plus plus, or like better, I will just increase here to k plus plus and I plus plus, right? It's just equivalent to k plus plus and I plus plus. So write any one of them, right? If this is not true, this means j has the lowest element, right? So we'll put else. Uh, okay, like we don't need to put else if, we can just else if. Else what we'll do answer k is equal to nums2j. This means j has the lowest element. Since the area sorted, so the lowest element will like ascending order, right? So 1, 2, 3, 5, 6. So first 1 will come, then 2, then 3. Of course, so 4 cannot come before, like 4 cannot come after 5. So 4 will come first, right? Now we need to shift pointer also. So we'll just k plus plus and j plus plus, right? This is the while condition when element are exhausted. Like if one matrix element are exhausted, like I showed you here in case number 2. Wait, yeah. Case number 2, when element 1, 2, 3 got pushed in, but these elements are left behind, right? So for that, I'll put while I less than m, right? What should I do here? I need to push again. Push without a condition. Answer of k is equal to answer nums I, right? Nums1 I. And once this happened, we need to shift pointer to, so we'll increment here only and I plus plus. This for num1. Like if num2 element are exhausted, means num1 element are pushed one in resultant, but num2 elements are left behind. So for that, while j less than n, answer k plus plus. Once they both got pushed between kings pointer, for that for that check I did k plus plus and nums2 j plus plus, right? Now we'll put semicolon. That I forgot. Yeah. So when all things are done, since they said कि answer num1 के terms में ही आना चाहिए, like we need not to make another matrix. So what shall I do? Since they are vector, so we'll just copy element nums1, wait, answer is equal to nums1, right? Let me check everything. Nums I k plus plus nums1. Yeah, we are good to go. We'll just run. What happened? 256. um, Element is stored in num1. Okay, sorry. Nums1 is equal to answer. Sorry, yeah, nums1. Now it run and we can submit. Yeah, so this is done. So thank you everyone.